Okay, so we're gonna go through the next few worksheets already. Okay, nearing the end of the mole. Okay, so let's start. So this is actually the homework which I gave you in the last lesson. Just double check that you have the answers correct. If there's any issues, do let me know. Okay, I want to go back to slide 11. I want to use the space at the bottom just to do a quick recap before we go on to the remaining segments for today. Okay, so what we have covered thus far, I'm going to use just triangles here. Okay, so those of you who are familiar with triangles, so we have learned how to interconvert between mole, okay, to mass, and what is the triangle that we are using to interconvert between them. Okay, so we know that mole, mr, if we multiply them together, we can get a mass. So this is the first thing that we have learned to interconvert between the mole and the mass. Is actually by using the MR. I'm not going to go through what MR is. If you need be, okay, go and revisit the previous segments. The next one we have learned how to calculate is from mole going to back and forth is the number of particles. Okay, it could be ions, atoms, or molecules. Okay, it could be ions, atoms, or molecules. What is the triangle that we have used for this? Okay, the top here, the bottom here is mole. This is 6 times 10 to the power 23. Down here will be number of particles. Okay, so as mentioned, particles can be atoms, can be molecules, can be ions. Okay, so we have learned to look at these two triangles here, learn how to interconvert between them. And the last one actually we have learned, okay, in our last lesson is actually what we call the molar volume. From the mole, we convert to the volume of a gas and interconvert back. How to go about doing this? Okay, mole at the bottom right left-hand corner. Now here will be 24 dm cube. Then this will be the volume of gas. Okay, so in the last segment, we also mentioned that 1 dm cube is actually equals to 1000 cm cube. Okay, so you need to know this. Okay, so these are the 3 that we have learned. And actually you realize that if you are able to find the number of moles, okay, you can interconvert between the mass to mole. You can find from mass the number of particles, number of to the volume of gas. So if I were to just summarize these 3 into a diagram to just link them up to see how we can interconvert between them, it's actually like this. So mole in the center, okay, I can interconvert between mass, interconvert like this. Okay, from mole, I can also get to the number of particles. And interconvert between this one will be volume of gas. Okay, so these are the 3 that we have actually learned to interconvert. Okay, so as a warm-up for today, okay, as I went through all this, as a warm-up for today, okay, I want us to just maybe at the start of today's lesson, I just want to go through, I want you all to try question 4, okay, try question 4, but I'm just going to run through a little bit of things first. Okay, so go to slide 12 now, okay, slide 12. Okay, we're going to run through question 4 first. Okay, so what is given the question? Whenever you're doing mole, it's always important to annotate because there's quite a bit of quantities given. By annotating, by underlining or highlighting and writing some notes, it will actually help you to minimize the amount of things in your mind, okay, and it helps you to process better. So let's start. 0.383 grams of a metal X. So I know this is the mass of X, okay? It is 0.383 gram. The AR is 23, so I know the AR. Next, they say that it reacts with 400 cm cube of fluorine. Okay, this is the volume of gas. To be more precise, instead of saying volume of gas, I will say that this is the volume of fluorine gas. Okay, but take note, this is in cm cube. So I'll put most probably an exclamation mark and say need convert to dm cube. Okay, exclamation mark. Then they say the two will react to form compound Y. So I know that the X plus the F2, okay, what's the ratio? I do not know. But they both will react to give me the compound Y. Okay, so X plus Y, X plus F2, okay, whatever ratio that they're reacting in is going to give me Y. So that's all the details I have so far. Now, let's start with the question A. A, what do they want? There's actually two things. Number of moles of X and number of moles of fluorine. So there's actually two things to find. Number of moles of X, number of moles of fluorine. Okay, so based on the conversions that based on the details I've shown you just now, I want you to really just take the next 3 minutes, next 3 minutes to just warm up and try 4A. Okay, so I'm gonna pause the recording. Give you 3 minutes. Please go and try the answers right now. So let's start. Okay, so for the first one, you're given a mass of X. Then I want to find the mole. So you know that I'm going to use a triangle. Mole, MR, mass. So somebody say, Che, this one no MR. MR is the relative molecular mass, right? So it's for molecule. But in this case, X is not a molecule. X is an atom, right? So we're going to use AR instead of MR. It's the same idea. It's the mass, okay, of X. Okay, relative molecular mass of X or relative atomic mass of X. So to find the mole, I take the mass divided by the MR. So this will be 0.383 divided by 23. So those of you who have your calculator and have done this, your answer should be 0.0167. Okay, mole. Take note, final answer always do 3SF. What's the number of moles of F2? Okay, this is where I'm going to use the triangle, volume of gas. I'm going to use mole and this 24 dm cube. So you know that this is in cm cube. I need to convert to dm cube, right? So the volume of gas, to convert cm cube to dm cube, I'm going to take 400 divided by 1000. Because this is to convert, okay? So I just want to highlight this, just a recap. So what I'm doing here, what I'm doing over here is to convert cm cube to dm cube. Okay, but this is still the volume of gas. So this whole thing here, it is still a volume of gas. Okay, so volume of gas now, since I convert to dm cube already, I'm going to take it to divide by 24. So you're going to write down here, divide by 24. So 400 divided by 1000 to get dm cube, then you divide by 24. Your final answer will be 0.0167 mole. Okay, this in terms of 3SF. Okay, I hope you all got the both of them are 0.0167. Okay, now calculate the number of moles of fluorine atom involved in the reaction. Look at this number of moles of fluorine atom. But what I have here is F2. F2 is a molecule. So what I know is this one cannot rush. Most probably what I need to do is, based on whatever I've seen here, I already got the mole. I need to convert to number of F2 particles. In this case, it's F2 molecules. From number of F2 particles, I'm going to convert to number of F particles. Okay, so this is the step I'm going to take, convert mole to number of particles. Okay, what triangle am I going to use? I'm going to use number of particles at the top here, mole, and then 6 times 10 power 23. Okay, so how many moles of fluorine atoms are involved here? I'm going to do these steps over here. From mole, convert to F2 particles. From F2 particles, convert to F particles. So let's start off with the first one. Number of F2 particles. Okay, this one I will go through for you, so you'll just copy down. So number of F2 particles in this case will be 0.0167 multiply by 6 times 10 to the power 23. So you take 0.0167 multiply by 6 times 10 to the power 23. You're going to get 1 0.00 times 10 to the power of 20. Okay, because this is working, so I'm going to leave it to 5 SF. So 1.0020 times 10 to the power of 22. Okay, 1.00220 times 10 to the power of 22. Okay, F2 particles. Okay, or you want to can put F2 molecules, it's the same thing. Now, this is for F2 molecules, but I want F atom. So what you know is that this is an F2 molecule, okay, where you got two fluorine chemically combined together. This is actually equals to 2 times of a fluorine atom. So I need 2 fluorine atoms to combine to give me my F2 molecules. So how can I convert F2 molecules into F atoms? So to find number of F atoms, is actually just equals to 1.0020 times 10 to the power of 22. Multiply this number by 2 because 1:2 ratio. You're going to get 2.00 times 10 to the power of 22. Okay. Okay, so this is a number of particles. Oh, actually, no, sorry, I realized I read wrongly. This is the number of moles of fluorine atom. I realized I shouldn't be counting particles. I'm sorry. Okay, this one, my mistake. I'm gonna erase the whole thing here. Okay, sorry. I'm gonna erase the whole thing here. This one, my bad. Okay. Instead of number of particles, it's actually number of moles of particles. So this one, let me change. Okay, give me a while. Let me erase everything. I say, thanks for whoever that texts me. Okay, to clarify this. Okay, so I realized this number of moles of the fluorine atom. So what we get, so let's rewind. This is the number of moles of fluorine atom. So I know that so this one is just looking at the F2. So I go back to the same concept. This is a fluorine molecule. This consists of 2 fluorine atoms. So if I know that I have 0.0167 mole of F2, okay, how many moles of F atoms will I have? So I think when you look at this, you can automatically tell me that, 0.0167 multiplied by 2, right? So, but we need to write the statement. So number of moles of F atoms, this is actually equivalent to 0.0167 multiplied by 2. So I'm going to get 0.0334 mole. Right? 0.0334 moles. So this is for part B. Done here. And last one, part C, determine the formula for compound Y. So I know Y, okay, consists of 0.0167 mole of X. This guy here also consists of 0.0334 mole of F. Okay, I purposely, so actually part B, right, instead of using F2, they actually ask you convert to F atom. So it's very simple. So because you know that X is to F, the ratio will be 0.0167 is to 0.0334. So we are using the mole to find the ratio between X and fluorine, or to determine the formula of Y. So if I look at this ratio here, if you were to look at both of them, you realize the ratio of X is to F is actually 1:2. So knowing this, you realize that Y will be actually equals to X F2. Okay, take some time here to digest how I get from here to here to here. So step 1 and step 2. Okay, maybe take the next 15 seconds to just look at where I get the numbers from, how I got to the ratio, okay, and how did I get to the formula. Okay, so take the next 15 seconds to just look at it. Okay, so I hope this is really just a warm-up in terms of interconversion, but I just want you to highlight this part C over here because this is something new. Okay, this is something new because you're using mole of the elements to find the formula of a compound. Okay, so take note of how you can use the ratio of the mole of the elements to go and find a compound. Okay, see this kind of question, okay, you may see in the exams here and there. Okay, so understand how it was being worked out. Okay, understand how it's being worked out. Okay, so this is actually not the main gist of it. This is actually all still warming up to just start your engine on what we have covered previously. Okay. One of the things that I actually did not say in terms of as we are running through it is actually that we actually have done on empirical formula as well. That one is actually just following the table and then using the ratio to go and find the actual molecular formula. Okay, that one I will not go through in detail. Okay, just going to recap on the previous worksheet because they're actually quite simple. Right now for today, we're going to go through the last conversion. Okay, I say here we're going to go through the last conversion. Okay, we're going to look at the concept of concentration. Okay, we're going to look at the concept of concentration. So in this worksheet, which is what we're going to complete for today, okay, we're going to learn what is the concentration of a solution, okay, with the unit gram per dm cube. This is in terms of mass and volume. We're going to look at concentration of solution. In this case, in the second one, is no longer gram per dm cube. Instead, we're going to look at concentration in terms of mole per dm cube. Okay, so this in terms of mole and volume. And the last one is learning how to interconvert between them. Okay, so this is what we're going to do in this worksheet. So let's start. Okay, let's start. Okay, a solution is made up of solute dissolved in a solvent. Solute dissolved in a solvent. So concentration can actually be used to describe the solution. Okay, so what exactly is concentration? Okay, define concentration. Concentration, okay, is actually so concentration of a solution. Take note, is concentration of a solution. Okay, is the amount of solute, or amount of solute dissolved in a unit volume of the solution. Okay, so the definition is the amount of solute dissolved in the unit volume of solution. When we talk about unit volume here, okay, typically in chemistry, our unit volume is, sorry, I realized I used highlighter. Okay, our unit volume that we're referring here actually would normally be 1 dm cube. So it's how much solute is dissolved in 1 dm cube. Okay, how much solute is dissolved in 1 dm cube. When we are looking at amount here, amount in this case can actually, in our syllabus, we can look at two things. It could either be looking at the mass of solute dissolved, okay, but if we don't use mass, we can actually also look at in terms of the mole of solute dissolved. Okay, so it can be either one. Okay, mass or mole. That's why our concentration actually has two different units. It could be gram per dm cube, which is mass over volume, or it could be mole per dm cube, which is mole divided by volume. Okay, so let's draw this now. Okay, so concentration can be expressed into gram per dm cube or mole per dm cube. We're gonna complete these two triangles here. If you look at both triangles, they look the same, but they are slightly different because here, the one on the left is gram per dm cube. The one on the right is mole per dm cube. So the triangle will look slightly different in terms of what I'm filling up. Okay, so concentration of solution, if it's in gram per dm cube, at the top here would actually be the mass, okay, mass of the solute. This one will actually be the volume. Okay, on the bottom right here is the volume of the solution. So for gram per dm cube, mass of solute at the top, volume of solution on the bottom right. Now, how about if it's a concentration of solution in mole per dm cube? At the top here, it will be in moles of the solute, okay, number of moles of the solute. At the bottom, it will be volume of the solution. So the difference lies in over here. Okay, mole. On the other hand, it will be mass gram per dm cube. Okay, so see the difference between the two triangles. Right? See the difference between the two triangles. Now, I want us to now try the triangle, but I'm just going to give you a little bit of clue here. Okay, so a solution of potassium hydroxide was prepared by dissolving 5 grams of potassium hydroxide in distilled water, and the volume is made up to 250 cm3. So what exactly is this? What exactly is this? Okay, we can figure it out. Question asks you what's the concentration in terms of gram per dm cube. Okay, so take the next 2 minutes, go and try question 2A based on the triangle. Choose the correct triangle, then work the answer out. Okay, take the next 2 minutes, go and try it out now. Okay, let's go. Okay, let's start from here now. Okay, so what I've circled here in the question, this is 5 gram. Actually, this is the mass of the solute. In this case, it's actually mass of KOH. 250 cm3 is actually the volume of the solution. Then they ask you what's the concentration. So what I'm going to use is triangle on the left-hand side here. So I want to find concentration is taking the mass divided by the volume. So take the mass divided by the volume. So mass is 5.0 gram. The volume, interestingly, do take note, they want in dm cube, right? So I'm going to put an exclamation mark and remind myself, need convert to dm cube. So actually, let me erase this. I'm not going to write like this. Instead, I'm going to write mass divided by volume. Okay, I'm just going to use the divide sign here. So the mass I know is 5.0. I need to divide it by the volume. The volume is actually 250, but I want to convert cm cube to dm cube. I need to divide by 1,000. So it will be 5.0 divided by 250 over 1,000. Okay, so 250. So 5. Okay, I'm going to work it out on my calculator. The answer you're going to get is 20 grams per dm cube. Okay, 20 grams per dm cube. Now, just want to make a little sense of it. Okay, instead of just purely learning how to calculate, what exactly does it mean when I say 20 grams per dm cube? So I'm going to use blue to just illustrate over here. Okay, so you can see here what I did was I take 5.0 grams of KOH and dissolve in 250 cm3 of water. 5.0 gram of KOH dissolved in 250 cm3 of water. Then when we say gram per dm cube, so actually the question would be, if I want to convert it to gram per dm cube, right? When I say 20 gram per dm cube, it means that to achieve the same concentration, if you want to have the same concentration, what you need to do is, if my water now becomes 1,000 cm3, I need how much KOH to dissolve in it? How much KOH needs to be dissolved in 1,000 cm3 for both to achieve the same concentration? So in this case, I will need 20.0 grams. Okay, 20 grams will do, 20 grams also. Okay. Okay, 20.0 grams of KOH to dissolve in 1,000 cm3 of water. Okay, so the meaning itself, concentration, okay, don't just purely calculate it. Try to understand how it works. Okay, try to understand what it means. Okay, instead of looking at 5 grams of KOH dissolved in 250 cm3, we can also start to think about, if I got 20 grams dissolved in 1,000 cm3, I take out 250 grams. How much KOH will actually be inside? It will actually be 5 grams. So the meaning can reverse on. Okay, the meaning can actually be understood in a reverse manner as well. Okay, so this is for 2A. We're going to try 2B now. Okay, what's the concentration of potassium hydroxide in 250 cm3 in mole per dm cube? So this is where the question comes. Sure, how do I go about doing this? Okay, how do I go about doing this? So this one, let me help a little bit. What I have is the mass of KOH, okay, which is 5 grams. What I have is the volume of KOH, which is 250 cm cube. So I know that if I want to find concentration in mole per dm cube, if I go back to the previous one, I need the mole of the solute. So how to find the mole of solute? Okay, so volume, sorry, this one is not volume of the solution, it's 250 cm cube. Now, so question is, I need mole. I got two quantities. So which one should I use to find mole? Should I use the mass of KOH or should I use the volume of a solution? This one volume, I can divide by 24. Answer is no. You cannot use this quantity. It cannot find mole. Let me write down. You cannot find mole using 250 divided by 24,000. You cannot. Why? Is because this 24 dm cube is actually only for volume of gas. Only for volume of gas. Okay, so gas. So therefore, I can't touch this. Okay, I can't touch this. The only one I can use is the mass of KOH. Mass can find mole? Answer is yes. So I'm going to use the triangle. Mass of KOH, mole, and MR. So you realize based on this, I need to first find what is the MR of KOH. So how to find the MR of KOH? I know there's 1K plus 1O plus 1H. 1K plus 1O plus 1H. How to find? This is 1 times 39 plus 1 times 16 plus 1 times 1. Okay, where 39, 16, and 1 come from? Just a quick recap. It is actually all the bottom number, the bigger number, which is the relative atomic mass. Right? So K is over here 39, O over here 16, H over here 1. So this is gonna be 56 if I'm not wrong. Okay, so that's the MR of KOH. Then now I'm gonna find the mole of KOH in 5 grams. So this would be 5 divided by 56. So 5 divided by 56. You're gonna get 0.089286 mole. Okay, down here I leave to 5 SF because this is not my final answer yet. My final answer is mole per dm cube. So I need to find concentration of KOH, which is gonna be mole, which is 0.089286 divided by 250 divided by 1,000. The divide by 1,000 is really because convert to dm cube. Just remember. So I'm gonna take this. Answer you're gonna get will be 0.357 mole per dm cube. Okay, 0.357 mole per dm cube. Okay, so this is for part B here. I'm not gonna go through part C yet. What I want you to do now is I want you to just take a look at question 3A. Okay, I want you to try 3A now. Okay, look at 3A. They tell you concentration is 2 mole per dm cube. 25 cm cube is used to neutralize. What's the number of moles of sulfuric acid present? Number of moles are. So go and try 3A now. Give you about 1 minute. Think of which triangle you're going to use, how you're going to find. Okay, so let's go. Okay, give you 1 minute to try this now. That's the answer. Let's look at this question. Okay, what is given here? So let's annotate again. I'll need underline for you. Annotate. So what is this? This is the concentration of H2SO4. Okay, the units given is mole per dm cube. This 25.0 cm cube is actually the volume of the solution. Okay, so then they ask you calculate the number of moles of sulfuric acid present. So come to understand this, 0.200 mole per dm cube. What does this actually means is that in 1 dm cube of solution, right, there's 0.200 mole of H2SO4 in 1 dm cube. Okay, so think proportion. 0.200 mole per dm cube actually tells you that there's 0.20 mole of H2SO4 in 1 dm cube. Then they tell you 25 cm cube is used. So then the question is, how many mole of H2SO4 is in 25 cm cube? So obviously when you look at this, you realize unit is different, so I need to convert, right? Okay, so but the idea is, you know that this one here, 1 dm cube, is actually 1000 cm cube. I'm going to only take out 25 cm cube out of the 1000. So obviously the number of moles here, this blank that I'm having here, okay, this will be less than 0.200 mole. Okay, because 1 dm cube or 1000 cm cube contains 0.200 mole. If I only take out 25 cm cube, by proportion, you know that this is going to be less than 0.200. So question is how many moles? Okay, so I'm going to apply the triangle here. So this is concentration in terms of the mole per dm cube. This will be the volume of the solution. This will be the number of moles. So I need moles is actually concentration times the volume. So let's find the mole of H2SO4. This will be equivalent to 0.200, okay, multiplied by the volume. Volume is 25, but this is in cm cube. I must convert to dm cube, so I divide by 1000. So this is gonna be 0.00500 mole per mole. Yeah, this 3 SF. Right, so I found the number of moles of H2SO4. Okay, I'm gonna do part B over here. I'm gonna do part B. So find the number of moles of hydrogen ions reacted. So if you go and look at the link, okay, so part A, you have done it already. I just want to show you the link from how did the H2SO4 sulfuric acid suddenly look at hydrogen ions. It's because you know that H2SO4, if you dissolve it in water, you're going to get 2H plus and 1 SO4 2 minus. So comparing the H2SO4 with the H plus, you know, okay, you'll be able to see that 1 H2SO4 is going to give me 2 H plus. So if I got 0.00500 mole of H2SO4, how many H plus, okay, how many mole of H plus will I have? Okay, looking at this on the left hand side over here, you know that to find the number of mole of H plus, this is actually equivalent to 0.00500 multiplied by 2. So we're going to get 0.0100 mole. Okay, this number of mole of H plus. Okay, number of mole of H plus. Okay, now when you look at part A and part B, you realize, this is not only concentration. You are jumping between mass to mole, jumping between number of particles, looking at the different quantities switching between another. Yes, you're right. Okay, because mole is not just between converting one to the other, just convert one of the quantity to mole, or you need to be able to interconvert between one another. So be very familiar with the various conversions. Or you look at what the question wants, and then from there try to convert. Last one, find the concentration of hydrogen ions in the dilute sulfuric acid. Okay, find the concentration of hydrogen ions in the dilute sulfuric acid. So I know that I know number of mole. They want concentration. How to find? So in this concentration, actually, they are looking at is the mole per dm cube of H plus. So I know my triangle. I need mole. I need volume. Then I can find concentration. So the question we must ask ourselves now is, This 0.10, sorry, I realize the color I have to see. This 0.010 mole of H plus. What is the volume? What is the volume of this 0.10 mole of H plus? Well, how much volume of the solution do I have? So if you read through the whole question again, part A is linked to part B, right? You realize, hey, actually I have the volume is actually 25 cm cube. The volume is actually 25 cm cube. So to find the concentration, you're going to take the mole divided by the volume. This will be 0.0100 divided by the volume, which is 25. But this in cm cube, I must convert to dm cube, so I divide by 1000. Okay, so I'm going to get 0.0100. Okay, your final answer will actually be equivalent to 0.400 mole per dm cube. Okay, so this is the calculation for part C over here. I'm gonna skip part C1 and part 2 on the previous one. Okay, I'm not gonna do these two. Okay, this part C, part 1 and part 2. I'm not going to go through now, okay, because I don't want to add any confusion here. This one will carry on later. So right now we're going to look at the next one. Really, this is to help us to learn how to interconvert between them. Okay, to learn how to interconvert them. So this is actually a diagram here. I want you to consolidate how to convert between the various stuff. Okay, how to convert the various stuff. So I'm going to show you what you're supposed to do. Okay, so each of the rectangle box, each of these boxes over here, this is actually the quantity, or a quantity that you can convert it to. Sorry, I realized I write wrongly. Please help to change this number of particles, number of particles of a substance. Okay, the units can either be atoms, molecules, or ions. Okay, sorry, this one right wrongly. So those in the rectangle boxes, they actually got the quantities they converted to. The arrows are actually the thing that you need to multiply or divide it with. Okay, so maybe let me show you another box. So number of moles for this box over here is actually the mass of a substance. The units will be gram. So how to convert mole to the mass? You must multiply by the mR. Hence, the mass to the number of moles, I know I must divide by mR. Okay, so I've adjusted the left-hand side for you. I've shown you how to do the on top one. Okay, I want you to try to complete the rest of the arrows and the other two blanks over here. Okay, so just maybe take the next 3 minutes, okay, next 3 minutes to just try to finish this diagram. Okay, let's go. Let's resume now. Okay, let's start from whatever that we currently have. Okay, so actually, if you remember all the stuff, right, everything will definitely start from mole 1. Okay, so the question is, which are the various boxes? So I'm gonna do from the bottom first. Number of moles, I can convert to the volume of a gas. Normally the units will be in dm cube over here. So to convert number of moles into volume of gas, I need to multiply by 24 dm cube, the molar volume. And if I want to convert volume of gas into the number of moles of substance, I'll need to divide by 24 dm cube. So this is what you should have at the bottom. So you say, this one can draw on the right-hand side. Answer is no. It's really because you got volume of gas here, you cannot convert to concentration. Okay, so actually at the bottom is volume of gas. On the right-hand side here, number of moles. I can actually convert this to concentration of a solution in terms of mole per dm cube. So how to convert mole into concentration in terms of mole per dm cube? I must divide by the volume of a solution. If I want to convert from mole to concentration to number of moles, I need to multiply by the volume of the solution. Okay, volume of the solution. Now, instead of looking at the concentration, which I didn't really say, okay, let's look at the mass of a substance to concentration in terms of gram per dm cube. This one you have done it also. So to convert grams to gram per dm cube, I need to divide by the volume of a solution. Okay, those of you who are very familiar with the units, I think you also understand why this will be divided by volume of solution. Okay, concentration of a solution convert to mass, this is actually multiplied by the volume of a solution. Okay, so this is what we have so far that I have taught you. Okay, this is what we have so far that I have taught you. Okay, based on all the triangles that we have drawn. The only one that we haven't really go through is actually on the last two. Okay, these two boxes here. These two boxes here. Okay, how to convert between these two? Concentration in gram per dm cube to concentration in terms of mole per dm cube. What's the units to use here? You realize both of them are per dm cube. So actually my focus could just be on the grams and the mole. So instead of looking at the per dm cube, which confuses things, actually just think of how you can convert gram to mole and mole to gram. So the blanks to fill up, okay, I should say to look at the conversion here. Gram to mole, this will be divided by the mr. From the mole to the grams is multiplied by mr. Okay, so this is actually all the interconversions that you will need to know. Okay, so I say again, this will actually be all the interconversions that you will need to know, okay, to help yourself be able to do all the interconversions. Okay, I say again, this all the interconversions you need to know in order to do all the interconversions. Okay, so let's start. Okay, looking at some of these questions here. So let's do a bit of practice. Okay, for the next 2 pages, actually you realize, these are all just interconversions. Yes, okay, these are actually just conversions, how to get from one to the other. So there's 2A, 2B, C, D, and E. So total got 5 parts. Okay, 5 parts to this question. So let's start from the first one. Okay, the question actually just asks you calculate the number of moles for each of the following substances. I want the number of moles for each of them. So what you're given at the start is 18 times 10 to the power 22 molecules of ozone. Down here, obviously, what they want you to find is the mole of ozone. Okay, so I want you to now take 1 minute to just go and try this question out quickly. Let's go. So to find number of moles of ozone, okay, what you're given molecules here, so you know that, okay, so those who are very familiar with triangles, yes, go ahead, use your triangles. But for part A, actually, we are looking at over here. Right, how to find number of particles, how to convert number of particles to mole. So if I follow the arrow, it's actually to divide by 6 times 10 to the power 23. So I'm going to take 18 times 10 to the power 22 divided by 6 times 10 to the power 23. Okay, so 18 to the power of 22. I'm going to divide it by 6 to the power 23. And your answer will actually be 0.300 mole, 3SF. Okay, so final answer, always do 3SF. So this was 2A. Okay, I hope you warm up a bit already. Let's go on to the next slide. What you're given is 76.25 grams of barium sulfate. I need to find the mole of barium sulfate. Okay, so once again, now quickly take the next 1.5 minutes. This one you need to do a bit more steps. So I'm going to give you 1.5 minutes to go and do this. Okay, let's go. So this is actually mass. This is mass. To convert mass to mole, I know that I'll need to divide by the mr. So barium sulfate, BaSO4. So I need to first thing find the mr of BaSO4. So what I did here, I actually pull out the details that you need. So this will actually be one. So to find the mr, it's actually the 1 barium atom, the mass, plus 1 sulfur, plus 4 oxygen. So it's actually 1 times 137, plus 1 times 32, plus 4 times 16. Okay, 4 times 16. So what you're going to have here is 137 plus 32 plus 4 times 16, you're going to get 233. So to find the mole is to take the mass, which is 76.25, You're going to divide by the MR. Sorry, my divide sign looks ugly. You're going to divide by the MR, which is 233. So 76.25 divided by 233. You're going to get a weird number. No worries about it, but just round it off to 3SF. You should get 0.327 mole. Okay, to 3SF. Okay? Okay, so this will be for part B. Now I want us to look at part C. Okay, this 36 cm cube of carbon dioxide gas. Okay, which one would you use? Which triangle? So next 1 minute. Okay, take next 1 minute. Go and try it out now. Okay, next 1 minute. The time starts now. Let's go. Let's go through this now. Okay, they give you 36 cm cube of carbon dioxide gas. So this gas here, this volume. So you know that this 36 cm cube of carbon dioxide gas is actually the volume of gas. So I want to convert mole to volume of gas. You know that you need to divide it by 24 dm cube. But this is in cm cube, right? So I need to convert my volume into dm cube first. Okay, so 36 divided by 1,000. This is to convert the cm cube into dm cube. Then I divide it by 24. So if you press your calculator, 36 divided by 1,000, then after you divide by 24, you're going to get 0.00150 mole. Okay, 0.00150 mole. So this rounded off to 3SF. Okay, so this for part C. Now, part D and part E, you realize that both of them are concentration, but this is gram per dm cube, this is mole per dm cube. So we're going to do part D first. Right, let's just focus on part D. Part D, you are supposed to find the mole of HCl. Okay, so take the next 1 minute. Okay, 1 minute again to just do part D. Okay, fast and furious. Your time starts now. Okay, so for this one here, what you are given is 25 cm cube. This is the volume of the solution. This one is the concentration of the solution because it's mole per dm cube. So to find mole, it's actually the volume multiplied by the concentration. Okay, but I'm going to write con D times volume lah. Now, because this mole per dm cube, I need to convert the volume to dm cube, right? So this will actually be 0.200 multiplied by 25 over 1,000. Okay, 25 over 1,000. So what I'm going to get here, okay, let me press my calculator. So this will actually be equivalent to 0.00500 mole. Okay, so this is for part D. Now, for part E, I'm going to help you a little bit because you realize that, sure, what you have given me is concentration, okay, in gram per dm cube. You have given me volume of the solution, but yet you're asking me to find the mole of KMnO4. So how to go about doing this? Okay, I want us to go back to the diagram that we have on the previous page. I know what's given to me is concentration. I want to end out in mole. So actually one way is to look at this diagram. Okay, you know that you're starting off over here. Okay, you're starting off here. You know you want to end off here. So this is the start. Okay, sorry, let me erase this. You know that this is the start. Let me use blue. This start. You want to end with number of moles. So there are actually two ways to get here. One is you convert to mass, then you convert to here. So this is the first method you can do, okay, which is in the blue arrow. The second way you can do is, which I'm going to illustrate in green arrow, will be to convert to mole per dm cube, then to convert to number of moles. Okay, I'm going to do the blue color arrow. So I'm going to convert gram per dm cube to mass. From mass, I'm going to convert to mole. Okay, so I say again, I'm going to convert the concentration to mass. I'm going to convert mass into mole. Okay, so let's go to the next page, come back here. So the step I'm going to take, which I'm going to write down here, I'm going to convert the concentration in terms of gram per dm cube. I'm going to convert this to the mass of the substance. How to do this? I'm going to multiply by the volume. From the mass, I'm going to do to find the mole. In this case, I'm going to divide by the relative molecular mass. Okay, so there are two, this one requires 2 steps. So to find the mole of KMnO4, you know, it's not just like that. Okay, there's 2 steps to do. So let's do the first step first. The first step is to find the mass of KMnO4 in 22.50 cm3. So I'm going to take the concentration, multiply by the volume. In this case, this will be 5.0 multiplied by 22.50 divided by 1,000, because I need to convert to dm cube. You're going to get 0.1125 mole. This is the mass. Okay, that's why you realize I put in, I never put in 3SF lah. After I get the mass, I need to find the mole. Okay, so the step 2, I need to find the mole, right? So it's actually mole of KMnO4 is, sorry, this is the mass. My units here wrong, mass, this one must be gram, my bad here, this is gram, From the mass, I need to find the mole. So I'm going to take 0.1125, the mass, divided by the MR. The MR is actually 1 potassium plus 1 Mn plus O4. So instead of writing all my things here, I will do a side step. So MR of KMnO4, this equals to 1K plus 1 Mn plus 4 O. Okay, so I can't remember Mn, what's the relative atomic mass. So I'm going to go and find it. So manganese is 55. So 1 times 39 plus 1 times 55 plus 4 times 16. Okay, so let's punch our calculators to just get the answer. 39 plus 55 plus 4 times 16, you get 158. So to find a mole, I'll take 0.1125 divided by its MR, which is 158. I'm gonna get the answer, which is 0.000712 mole. Okay, 0.000712 mole. So this is the answer. Right, so we have gone through all of this now. I hope you are at least more familiar with the interconversion. You know how to use your triangles properly. Okay, those of you who are now able to look at this diagram and understand how to use it, you can actually use this as well. Okay, so there's no one diagram. You can use a triangle, you can use this table. I leave it, this flow diagram, I leave it up to you. Okay, but make sure that you are able to interconvert between them. Be very familiar with it. Okay, so homework. Okay, I'm gonna adjust this question, this question a little bit. Okay, I'm gonna write on your main paper. So let me go to your slide 14 on the main paper. So I'm gonna edit, go to slide 14. Okay, so I'm not gonna put C here. I'm gonna cancel this. Okay, I'm gonna recraft a question on the spot now. Okay, so instead of looking at 25 cm of potassium was pipetted into a conical flask, I will put okay, 25 cm cube of 5, don't want to use 5, 5 so many times, of 12.5 grams. Okay, so 25 cm cube of 12.5 grams per dm. Okay, sorry, maybe let me rephrase. I prepared a conical flask. Its concentration is 12.5 gram per dm cube. Okay, its concentration is 12.5 gram per dm cube. Then you're going to try part 1, then you're going to try part 2. Okay, so I say now this will be your homework, this whole question here. I recrafted it. So imagine it's not linked to the previous part. Okay, not linked to previous part. I want you to try this. Okay. So 25 cm cube of potassium hydroxide solution is prepared into conical flask. Its concentration is 12.5 gram per dm cube. Go and find the number of moles of potassium hydroxide. Go and calculate the concentration in terms of mole per dm cube. Okay, so this will be your homework for today. And actually, we are done with mole. Okay, when school reopen, you're having your camp. Let me stop this. Okay, so I'm gonna stop the recording.